Okay, Calculate. So today we're going to look at a volume that we can find using two methods, one of those being shells, and I want you to see why shells can actually be easier. So I first want you to pause the video and get all of this shaded region graphed. So hopefully you have a shaded region that looks like this. And my spin axis is going to be the y-axis, and first I'm going to ask, if you had a choice between just discs and washers, which of those two would you pick? And hopefully you're all shouting out at the same time, washers, because of course there's a gap in here. So I would use washers because it has a gap. And if I'm spinning around the y-axis, that would make this a dy problem. So I'm going to use dy, which means I need my equations to be in x equals. And so of course that's a slight problem because this one up here is not x equals. But if I do a little hocus pocus math magic, I'll end up with x equals plus or minus the square root of 1 over y. And that transforms into the picture. I just did not graph all of 1 over x squared. If you graph all of 1 over x squared, you actually have a duplicate copy on the other side of the curve. But since I wasn't shading in and around that with the x equals 1/2, x equals 3, I just didn't bother to draw it. So this side is really just the positive side. And that's really all I need to concern myself with. Okay, so now if I start drawing in the radii, a few of them, just to start to see what they look like. Of course, I can see that there's a gap. And my first question would be, are the radii equal? And what I hope you would say is no, but I do notice that some of them are in fact equal. These ones down here, I'm going to call those the lower ones, and these ones are the upper ones. And so what that means is I'm going to have to integrate separately. Now, it's going to be important that I actually know where this hits the graph. So if I figure out what the coordinates are, up here, the coordinate of intersection was 1/2, 4. And here the coordinate of intersection was 3, 1/9. Can always go back and plug in 3 and 1/2 into y equals 1 over x squared if you're not convinced. And so, of course, my radii in the upper piece, I would be doing right minus left. We're going to make a note over here on the upper. So right minus left. And if I look at the large radius, which is the whole length, I would be going from the square root of 1 over y minus 0, that's capital R. And if I look at lowercase r, that's just the stuff in the gap. And right minus left would be 1/2 minus 0. And so now, when I integrate, I would have capital R squared minus lowercase r squared. This is a dy, and I need pi because I'm doing pi r squared for the discs or the washers. And then, since I'm integrating with respect to y, now, for these particular radii, they are all the ones in the upper only. So I have to decide, where does the upper and lower each start? And of course it's at this intersection point, because from this yellow line up, all the radii have the square root of 1 over y as their right, versus all the radii from this point down have a different right value. It's not the square root of 1 over y. So I'm actually going to talk about this upper as section A, and we'll talk about the lower as section B. So this lower is really this stuff down here. So now I just found the upper. Now, so I need to know the boundaries of just the upper. And of course, they need to be y values. So that lowest y value is 1/9. Keep in mind that's from this intersection point. And the highest y value is 4, also from the intersection point. And then I'm going to have to add the lower section. So now the lower section, the right, is 3, x equals 3, minus 0. And little r, keep in mind little r is this stuff sitting right here, and the right minus the left of that is 1/2 minus 0. So when I integrate this, I get capital R squared minus lowercase r squared, again with respect to y. And now the y values on this lower section only are from 0 to 1/9. Notice how they connect, 1/9 here, 1/9 here. And that should always happen. That's what connects the two sections together. Okay, so now I'll leave you on your own to actually get to this answer. I got 11.25 for this one. See if you can get that either by hand or by calculator. Alright, see you in the next video where we do shells.